Okay, all right. So this is over now because these 4 formulas we need. And why there is a minus sign here? Because I hope you have understood it. Because if you swap this, if you do sine c minus d, then this is the same thing as sine minus d and minus of this whole thing. Okay, this thing is the same thing as minus of this whole thing, which gets you minus at front. Okay, so I hope this is easy. Now it's time to prove these identities. Okay, so let's prove them. Let's prove them. So you want to prove the first one. How do you prove it? So this comes from our old identity. Which identity?
Old.
So by old I mean product to sum identity. So these all of these sum to product identities, just another way of writing the same thing. Product to sum identities, but in another way. Okay, so it just comes from. So it comes from product to sum identities, product to sum. Okay, so it comes from product to sum. So what identity? I mean, which product to sum identity is associated with this one? You can see that here we have sine and cosine. All right. So this is same thing. I mean, this is associated with sine A cosine B. So what's that? What is the identity of this? This is half sine A plus B plus sine A minus B. I hope you can remember this. If you can't, then check out your notes. Because sine A cosine B, how do I know that this is associated with sine A cosine B? Because here is sine apparent and there is cosine apparent. So sine A cosine B, and this formula is half sine A plus B plus sine A minus B. This is associated with that. Now what are you going to do? You're going to form an opposite or inverse relationship such that if you know this, we can figure out what is going to be on this side. Okay? So let's say this thing is known and the sum is known. Does that make sense? This whole thing is known. We're going to figure out how we can write in terms of product. From sum, we are interested in writing in product form. Okay, so we want to form product. Okay, we want to form this. Sum to product. Sum to product. We want to form now sum to product. How does it look like if you do it from sum to product? So how are you going to transform this from sum to product? This angle is known. So A plus B is some angle C. Okay. And A minus B is another angle D. So these are known in terms of C and D's, like this here. Sine C plus sine D, sine C plus sine D is known here. And you have to figure out what this becomes on the product side. Okay? So first of all, you have to figure out what these A's and B's will be here. Okay? So what those A's and B's will be here. So add them up. So this BB cancels out. And this will be 2A is equal to C plus D, and you're going to have the value of A as C plus D over 2. If you substitute it back into one of these equations, then you can figure out that B is going to be C minus D over 2. Try it on your own, you can see. So this is going to be the values of A and B's, A and B. Okay, there's only one A and one B, so I shouldn't say A's and B's. Okay. So A will be this, B will be this right over here. Now what are you going to do? We know this side, we don't know this side. So we're going to substitute for A's and B's as a function of C and D's. C and D's are known. So we're going to do the reverse now. Now we are forming from sum to product. Okay? Does that make sense? So how is it going to look like? It's going to look like, so let's do it beneath here. So this will be just transformed. This identity will be transformed. So sine A, instead of A, I'm going to write it in terms of C and D's. Okay? So instead of A, I'm going to write C plus D over 2. Alright? And this is A. Sine A cosine B. So this is cosine, and B is C minus D over 2. Okay? So sine A cosine B. And this is equal to half. So so this is equal to half. But if I bring the half onto this side, then this will be multiplication of 2. Factor of 2 will come on this side. And on this side, I'll be left with sine a plus b, and a plus b we know c, because c's and d's are known, and a's and b's are unknowns in this case. Okay, we want to write a's and b's as a function of c's and d's, because the right side now is known in this case. We want to write a function from right side to left side. We want to have an identity from right side to left side. Okay, sometimes I misuse words, as I said, function from right to, that's some misuse, okay, of word, because a is function of c's and d's here. Okay, what is okay, this what is correct when I talk about this. Okay, so sine c plus sine d. Does that make sense? Because sine c plus sine d. Sine c plus sine d. So what it means? It means sine c plus sine d is 2 sine c plus d over 2 times cosine c over d over 2. So this is just the manipulation of the identities that we already know. Okay? Okay? So the identities that we already know is just the manipulation such that we are able to write from right side to the left. Okay? So what the result we got from this? So the result that we got is this. So the result is this. That sine c plus sine d is equal to 2 sine c plus d over 2 times cosine c minus d over 2. So this is it, and you can do the same thing for all the other identities as well. Okay, for all the other identities as well. Number 2, the next identity. Okay, so this is the result. Okay, so the result is known to you already here, so I'm not going to write this again to waste space. Number 2 is sine c minus sine d. So what I'm doing here, I'm writing here the result first and then proving it. You can do it in the reverse order as well. Prove this first using the product to some identities, and then derive sum to product identities. But right now I'm writing the result first. It doesn't matter what I do. Do I write the result first, or do I just derive it on the way? Okay, on the fly, or if I just write the result first, doesn't matter. It doesn't matter. Okay. All right. So I'm stepping on the wire. So this is 2 cosine c plus d over 2 times sine c minus d over 2. How do I prove it? So what I didn't prove, I want you to prove it. As long as I do it here, you do it on your notes. Okay, so the first thing is that we have to figure out which identity, which product to some identity is related to this. So yeah, so here we can see cosine and sine is appearing. So it is related to cosine A, cosine B. So which is related to cosine A, cosine B? I'm sorry, sine B. It should be sine B. So what is related to cosine A, sine B? It is half sine, okay, am I wrong? Cosine is going to be. So cosine A minus B minus cosine A plus B. It is this, and we have to manipulate this identity. So, okay, and we already know what A's and B's will be. If you let A plus B to be C, and if you let A minus B to be D, then it turns out that A is C plus D over 2 and B is C minus D over 2. And now you can do it you can derive for what cosine C plus minus cosine D is here. Okay, wait a minute. Okay, so I used the wrong formula here. So this is what it matters here. If you use the wrong formula, you're gonna have another thing proved. Okay. So I have cosine and sine. So I'm looking for cosine A, sine B. So not another thing proved. That was completely wrong. because the foundation is wrong, then it leads you the wrong thing. Yeah, cosine A sine B. So what cosine A sine B, I mean, in which formula cosine A sine B is involved? Then in the formula of sine A minus B, as you can remember. What is the formula of sine A minus B? Okay, now. Yeah, sine A plus B and sine A minus B. What is the formula of sine A plus B? Sine A cosine B plus cosine A sine B. And as you can see here, cosine and sine are in formula of A plus B and A minus B. So it's going to be and cosine is first. So it's going to be sine A plus B and minus here, because cosine is first, not sine. So sine A plus B minus sine A minus B. If you can't remember this, then you can check out your notes, because I also sometimes can't remember that. Now let's build up from this. We know the C's and D's are, okay, so I don't need to write again and again. This is A's and B's. Let's plug this in. So this is going to be cosine. What is going to be A here? C plus D over 2. What is going to be sine, and what is going to be B here? C minus D over 2. And this is going to be equal to half times sine C minus sine D. And as you can see here, that sine C minus sine D comes in the form of cosine and sine. Cosine and sine. This is the right approach. We headed in the right direction. Okay. Okay. For some people, it might seem that we are building this. Building the proof from this, but we're not. Okay. We could do. You could do the proof first and then write the result. Okay. Which I'm going to do in the third example. I'm not going to write the result first. I'm going to do the proof first. All right. So let's see. So this is going to be 2 cosine C plus D over 2 times sine C minus D over 2 is sine C minus sine D. This is what it is. Sine C minus sine D is 2 cosine C plus D over 2 times sine C minus D over 2. So here we have the result proven. Okay, now let's go to the third one. And in the third one, for your understanding, I'm not going to write the result. I'm just going to do it from scratch. Okay, I'm going to prove it and then write the result. Because for some people,